All right, let's crack a code, a mathematical one. Our mission for today is pretty simple. We're going to investigate, break down, and totally master how to find the volume of a sphere. So let's jump right in.
So, here's our game plan. First, we'll nail down the basics. Then, we'll get our hands on the key, the formula itself. After that, we'll dive into a case study, throw in a little twist just for fun, and wrap it all up with the most important takeaways. It's kind of like a 5-part mystery, and we're going to solve it together.
Okay, first things first, what even is a sphere? Well, just picture a perfectly round 3D object, like a basketball or maybe a marble. And when we're talking about its volume, we're not talking about the outside shell. Nope, we want to know how much stuff you can fit inside it. That's the key. Now, this is super important, so listen up. It's really easy to mix up area and volume. Area is flat, right? It's about covering a 2D surface, which is why we use units like square inches. But volume is all about the space inside a 3D object. And the biggest giveaway? The units are always cubed. You see that little 3? That's your clue that you're in the 3D world. It might seem like a tiny detail, but trust me, it makes all the difference.
So the big question is, how do we actually figure out how much space is in there? Well, to crack this whole thing wide open, we need a special tool. It's like our master key, and it's a formula.
And there it is. V equals 4/3 pi r cubed. I know, it might look a little scary with the fraction and the little 3 and everything, but I promise you, it's not as bad as it looks. Once we unpack it, you'll see it's actually pretty simple and super powerful.
So let's deconstruct this thing. V, that's easy. It's the volume, the thing we're trying to find. Then you've got pi, which is just that special number, about 3.14. R is the radius, which is just the distance from the dead center of the sphere out to the edge. And the real star of the show? That little 3. That means we cube the radius. In other words, we just multiply it by itself 3 times. R times R times R. Okay, let me give you a serious pro tip here. Look, in geometry, you're going to be juggling a ton of formulas, right? For cones, cylinders, pyramids, it's a lot, and it's so easy to mix them up. So please, don't just try to remember it all. That's what notes are for. The best problem solvers always double-check their notes to make sure they're using the right tool for the job.
All right, enough with the theory. Theory's great, but let's see this thing in action. It's time to open up our first case file and put this formula to the test with a real example.
So here's the deal. Case file number 1. We've got a sphere. We know its radius is exactly 3 inches. Your mission, should you choose to accept it, is to find its volume. Ready?
Let's walk through this together, step by step. Step 1. Always write down the formula. V equals 4/3 pi r cubed. Got it? Step 2, we plug in what we know. So we swap out that r for a 3. Easy enough. Now step 3 is where people mess up, so pay close attention. Order of operations. You've got to deal with that exponent first before anything else. So 3 cubed, well, that's 3 times 3 times 3, which is 27. Once you have that, the rest is just simple multiplication.
And boom, that gives us our answer. 36 pi cubic inches. Now, this is what we call the exact answer. Why? Because we haven't rounded pi or anything. We just leave the symbol there. It's the most precise way to write it. So if a teacher ever asks for the exact answer, this is what they're looking for. But in the real world, you probably want an actual number you can work with. So if we substitute 3.14 for pi and do the math, we get about 113.04 cubic inches. See that little squiggly equal sign? That just means approximately equal to. So both answers are right, they're just used for different things. Okay, nice job. We figured it out. But what if the problem was flipped on its head? Let's try something a little different to really make sure we've got this down. This time, we're going to work backwards.
Okay, case file number 2. The situation has changed. This time, we already know the volume. It's 113.04 cubic inches. What we don't know is the radius. So how in the world do we find that?
Well, we start with the exact same formula, only this time we're solving for r. So first, we plug in the volume we know. Now it just becomes an algebra problem. Our goal is to get that r all by itself. We'll multiply by 3 to get rid of that pesky fraction, then we'll divide by 4 times pi to isolate the r cubed. After you punch that into a calculator, you'll find that r cubed is 27. So the last step is to take the cube root. And don't let the name scare you. It's just asking a simple question, what number times itself again gives you 27?
And what do you know? The answer is 3. The radius is 3 inches. Mystery solved. How cool is that? It just proves that this formula is a two-way street. It works perfectly forwards and backwards. It's a really elegant little piece of math.
So we've cracked this thing from both sides. Pretty awesome. Now it's time for the debrief. Let's boil everything we just did down to the absolute must-know key takeaways. Honestly, it all comes down to these three things. If you can remember these, you'll nail it every time. Number 1, use your notes. Don't guess the formula. Number 2, watch your units. Volume is always, always cubed. And number 3, the order of operations is king. Exponents always come before you multiply. Get those 3 things down, and you've basically mastered the volume of a sphere. And just like that, our investigation is closed. We've totally cracked the code on a sphere's volume. But you know, solving one mystery always leads to another, doesn't it? It makes you wonder, what other secrets does a sphere have? Like, what about its surface area? Now that sounds like a whole new case waiting to be solved.